Hello, welcome back to Math with Patrick. Today is August 14th, and we're solving problem number 226 from this Daily Epsilon calendar. And hopefully the answer today is 14. It's supposed to match the day's date, so our answer should be 14. And whenever there aren't written instructions in this calendar, we're just assuming that we're solving for x. So x should be 14 today, and y and z are, well, they're probably going to be other numbers. They might be 14 as well, but it's unlikely. And all we're really doing is just solving for x. So we have ahead of us a system of three equations with three unknowns. And typically, when the amount of equations you have matches the amount of unknowns you can solve for all the unknowns. So I know that we're kind of set up for success here, and there is probably a solution out of this. One way to visualize what's going on, maybe you've seen equations like this. This would be a standard form linear equation in 2 dimensions, and so it'd just be like a line on the plane. But introducing this z variable here makes me think in 3 dimensions instead. So we would have like a z-axis coming out from the page. Actually, with the right-hand rule, yeah, okay. There's a trick to remember which way the z-axis is supposed to go, and if that's x and y, then yeah, z should come out of the page. So we're in 3 dimensions right now, but ultimately we still have some kind of line crossing somewhere in 3-dimensional space. So, I mean, it could be the case that when you do a problem like this with 3 different 3-variable equations, maybe you're going to come across a case where none of them intersect each other. Like maybe this line right here is kind of below the other two. And so it's entirely possible in this kind of setup that we don't even get a solution between, or like a value for x, y, and z. But given the expectation of x being 14, we'll probably get one solution. So let's try it out. I want to eliminate some variables, get rid of some variables. So I'm turning a problem with 3 variables into a problem with 2. I'm noticing that these 2 equations have a positive z and a negative z, and so I want to do something with these. So this equation, we're assuming it's true, and so I know that 2x minus 3y plus z is equal to 24. And then we have to assume that this equation is true as well, so we know that this value and that value are identical. So if I add this to the left-hand side, I am allowed to add 22 to the right-hand side, and my equation is still going to be balanced because these 2 values that I'm adding on the left and right sides are the same. So I'm allowed to add 3x, a negative 5y, and a negative z to the left side and balance it out with a positive 22 on the right-hand side. And again, my goal was, with this addition, I'm eliminating or getting rid of this z. So we do get 5x minus 8y is equal to 46. And then ideally, I need another equation with x and y to play around with to eliminate probably the y. So I already used this equation and that equation to get this one. And so I should pull either these 2 together or these 2 together and eliminate z again so that I can pare this down from 3 variables to 2. I think what I'd like to do is take this equation and this equation. I'm going to take the bottom equation and multiply both sides by 6. So multiplying the 3x by 6, I'll get 18x. Multiplying this negative 5y by 6, I'll get negative 30y. Multiplying this minus z or negative z by 6, I'll get minus 6z. And then multiplying 22 by 6 gets me whatever 120 plus 12 is, which is 132. And the reason why I multiplied it by 6 is because I wanted to line up the z's again and cancel those out. So I will kind of line up the x minus 4y plus 6z equals 32 over here. And I'll do the same idea as before, where on the left side, I will add all of this stuff. And on the right side, I will add the 132. And since I know that these two expressions are equal, I'm allowed to add them on either side of my equation. I will get 19x negative 34y. And then again, my whole goal was to get these z's to cancel out, and they do. 6z plus negative 6z is no z's at all. And then we get 32 plus 132, which is 164. So now I need to have these two equations talk to each other. The 5x minus 8y equals 46 equation, and the one that I just produced over here. Ultimately, we are solving for x today, so I'm going to see what I can do to eliminate this y. And it looks like I'll actually need to multiply both equations here. I can't match the 8 up to the 34 because 34 is just not a multiple of 8. So I need to change this number here to, basically I need to find their least common multiple. 34, let's see, that is going to be 17 times 2, I believe, because that's 20 plus 14. And then 8 is 2 times 2 times 2. And to find their least common multiple, I essentially just need to multiply on any factors like that I don't see here and I do see here. I need to kind of have them share, essentially. So I already see a bunch of 2's down here, so I don't need to multiply any 2's to my 8, but I do need to bring in the 17 because that wasn't down there. Likewise, I only have 1 2 up here, and I need at least 3 to find a least common multiple. So I need to kind of get these 2's up there. And then ultimately, to find this least common multiple, I could either multiply 34 by 4, or I could multiply 8 by 17, and I'll get the same number. 34 times 4 just feels a little bit more approachable to me. I'll do 4 times 4, which is 16, 4 times 30, which is 120, and I get 136. And so that is going to be the least common multiple for my y's. So let's try this out. I multiplied this by 4, and I multiplied this by 17 to get 136. So I need to distribute this 4 to all 3 of these terms up here. 4 times 20 is 80, so that means 4 times 19 should be 1 less 4. I already did this math. 4 times 34 is 136. And then 4 times 64 is going to be 400 plus 128 plus 128. I'm just doing a lot of weird distributing in my head, but that's just what made the most sense to me. So let's add these. 8 plus 8 is 16. Carry the 1. That's a 5. That's a 6. 656. All right. And then now we need to multiply through that 17 to the other equation. 17 times 8, I'm hoping, is 136. I didn't actually do that in my head. I just kind of trusted my math from earlier. 17 times 5 is going to be the same as 50 plus 35. So that's going to be 85x. And then 17 times 46. I don't have any quick tricks there, so I'm just going to run through the long multiplication. 7 times 6 is 42. 7 times 4 is 28. Add the 4. Placeholder 0 for my 10. 1 times 46 is 46. Add these up. We get 782. I'm really hoping that my arithmetic is right here. It could be entirely wrong, and that would kind of suck, but I'm feeling like I haven't made any mistakes. I think I will actually put this equation on top of the other one because I think it'll be nice to subtract one equation from the other here. And I do like to subtract when my top values are bigger than the bottom ones. So subtracting will cancel these terms out. Negative 136 minus another negative 136. You can think of these as like adding. Ultimately, my y's will cancel out, which is exactly what I wanted because I want to isolate just the x that should match today's date of 14. 85 minus 76, that is 9. So we have 9x. These cancel out. And then let's do the subtraction here. A little bit of borrowing. That's going to be a 6. That's a 2. That's a 1. We just need to figure out what 126 divided by 9 is. And then why not? Let's just do a little bit of long division. 9 fits into 12 once. And then when we subtract, we can do 12 minus 9 and get a 3. Drop down the 6. 9 goes into 36 exactly 4 times. And that shows me that x is indeed 14 today. So that's kind of like the classic way to solve it. And it takes a while, right? It takes like these 2 steps to eliminate the z variable, eliminate the y variable, and finally we know what x is. If you're curious, I want to essentially go to Desmos instead. I'll type these equations in, and then we can visualize on a 3D graph to do a different solution or a different method to find y and z, because I really don't want to do all this algebra and arithmetic for those variables. So I'm going to hop over to Desmos. So this is desmos.com/3D. You do need to go to a slightly different URL than the usual desmos.com/calculator. And here are our 3 different equations. Let me punch in the final step, or the final numbers rather. We got 24, a 32, and a... Oh, these are planes. Huh. Oh well. I really thought they were lines, but I guess I was wrong. Anyways, we got 3 planes, and you can kind of tell how on like this side, that opening is pretty big. On this side, it is getting a little bit smaller. And so if I zoom out just a touch, I'm assuming all of these 3 will overlap. There we go. So right there is our solution. And to like interpret it, I'm trying to find like the x, y, and z axes. This -10 right here is for our y-axis. You can kind of see how the y is right there. Here's +10, there's -10. I think this number right here is a 10 for x. This is a +10. So like just reading the graph, I know that each of these squares is counting up by 2s. So 2, 4, 6, 8, 10. And then 12, 14 is going to be the edge of this graph right here, at least for our x values. So it does make sense that this right here is at the edge of this box, because that is where x is 14. So let's see if I can kind of visualize and estimate, or hopefully get the actual precise value for y and z, just kind of based on where it is on the graph. So I can write some points. It needs to be a triple ordered pair. X comes first, then y, then z. X we know is 14 because we did the algebra for it. Y looks like it is maybe, what is that? 1.5 tick marks up. So maybe that's 2 and then 3 to get the y value. So maybe y is 3. And then z, how many tick marks up do you think that is? Maybe that would be like 1, 2, 3 hops. So maybe z is 6. Okay, I overshot it. Z is 5. Zoom out just a touch. I guess, yeah. There we go. That's a nice spot for us to double check that like the red plane, the blue plane, and the green plane are all intersecting each other just right there. You know, we can kind of see from all different sides that that point seems to satisfy at least the planes. So we should just double check that that point right here represents our solution by running through the math of it all. So if we plug in a 14 here, and then plug in a 3 here, and then plug in a 5 here, hopefully we do get 24. Cool, then we do. And then I'm going to do this for the other 2 equations just to be sure. So that x should be a 14, this y should be a 3, that z should be a 5, and then this left-hand side hopefully is 32. There it is. And then finally, let's grab this one. The x should be a 14, the y should be a 5, nope, the y should be a 3, and the z should be a 5, and that is 22. There we go. So this special trio of numbers, 14 for x, 3 for y, 5 for z, satisfies all three of our equations, and we can see it visually here. That's where the planes intersect. And then we can also verify it by just plugging in the values and seeing that all of our equations are happy. So there it is. That is our solution. I hope you enjoyed. I'll see you tomorrow. Bye.